Hello, Tor Lacey here, with a lecture about mountains. Earth's geologically young, growing mountains are found in patterns on Earth's continents. Patterns in nature happen for a reason. In the case of mountains, you already know the cause. Plate tectonics. More specifically, mountains are built along convergent or divergent plate boundaries. Generally speaking, we recognize four types of mountains on Earth, based on how they were constructed. Volcanic mountains erupt lava and pyroclastic material. These can form above hotspots, like the Hawaiian Islands, but most form along plate boundaries where magma is made through subduction or continental rifting. In this image, subduction is making magma. Magma is less dense than the surrounding lithosphere, so it rises to the Earth's surface. After many eruptions and many thousands of years, a volcanic mountain is built up. Lines of volcanoes parallel to a deep ocean trench are called a volcanic island or continental volcanic arc, depending on whether they are part of the oceanic or continental crust. The Cascade Range in the Pacific Northwest is an example of a continental volcanic arc. Mount St. Helens is probably the best known volcano of the Cascade Range. This photo was taken shortly after its famous 1980 eruption. The processes needed to make granite batholith mountains are partially the same as those that make volcanoes. Subduction makes magma, which rises towards Earth's surface. However, most of this magma never makes it to the surface before it loses sufficient heat to solidify into a body of intrusive igneous rock, like granite, called a batholith. This happens 10 to 15 miles deep, so additional geologic work is needed for this material to be exposed on Earth's surface to become a mountain. This additional geologic work comes in the form of tectonic and isostatic uplift, which very slowly brings the intrusive rock to the surface, and erosion, which strips away the overlying layers. Tectonic uplift refers to movement along faults, and isostatic uplift is the tendency of a less dense object to slowly rise through more dense material. Think of how an ice cube rises to the top of your beverage. The Sierra Nevada mountains in California are an excellent example of a granite batholith mountain, having been formed through the aggregation of 100 or so individual batholiths. Since granite is resistant to weathering and erosion, it's good material for supporting tall, steep mountain peaks. Folded mountains form in response to compressional stress along convergent plate boundaries. This causes rock to be folded into structures like anticlines and synclines, or to break along reverse faults. This shortens the crust horizontally and thickens it vertically, resulting in mountain building. Faulted mountains grow by movement along faults during earthquakes. In regions of continental rifting, like East Africa or the Basin Range in Nevada and eastern California, uplift will be along normal faults. Near convergent boundaries and some transform boundaries, movement along reverse faults drives the upward movement of the crust. We see this happening here in Southern California, where the San Gabriel Mountains are growing due to uplift along the Sierra Madre Thrust, a zone of reverse faults that trend along the base of the mountains and through cities like Pasadena and Rancho Cucamonga. This lecture summarized how each of Earth's four different types of mountains are formed. Volcanic mountains grow through repeated eruptions of lava and pyroclastic material, often along convergent plate boundaries. Granite batholith mountains also are related to subduction and making magma, but they are made from large masses of solidified magma called batholiths that are slowly brought to Earth's surface over long periods of time. Folded mountains form as the crust is crumpled and thickened due to squeezing from compressional stress. Faulted mountains grow by movement along reverse or normal faults, or blocks of crust intermittently slide upward along faults, eventually becoming prominent enough to be considered mountains. Okay, that's it for this lecture. Thank you for listening.